In this video, I'm going to do some questions related to discrete and continuous random variables. These questions will be based on the concept which we have learned so far in the previous videos. So now, without any further ado, let's get started. So in the first question, you are given the CDF. So when x is less than or equal to 0, the value of CDF is 0, and when x is greater than 0 but less than 1, the CDF is x, and when x is greater than 1, the CDF is 1. You are asked to calculate probability density function for the random variable. Okay, so now let's draw the graph of CDF first. So on the x-axis we have random variable x, and on the y-axis we have CDF. So you can see that in the range 0 to 1, suppose this is 1, the graph is a straight line passing through the origin, right? So suppose this is the graph until 1, and after 1 the graph is a horizontal line parallel to the x-axis. Okay, so clearly we can see that this is the random variable is a continuous random variable because the graph is no longer a step function. All right, so this is a continuous random variable. Now we know that if we want to go from PDF to CDF, we need to integrate the function. Okay, and if you want to go from CDF to PDF, then you need to differentiate the function. All right, so now in this case, in this example, you are given the CDF, so you need to differentiate the function in order to obtain the PDF. Okay, so let's differentiate the function. So our function is x, so the differentiation of x, okay, let me write the CDF first. The differentiation of x is simply 1. So the PDF is 1, and please do not forget to write the range of x, which is 0 to 1. All right, so this is how we can solve this question. Let's move on to the next question. You are given the PDF when y is greater than 2 but less than 4. The PDF is 1 over 8 times y plus 1, and elsewhere it is 0. And you are asked to calculate the probability when y is less than 3.2 and probability when y is greater than 2.9 but less than 3.2. So in this question, it is better to find out the CDF first, and then we'll calculate the probability by substituting the values. Okay, so let's calculate the CDF up to the point y. Okay, then we'll put the value 3.2 and 2.9 in place of y. So our lower limit is 2, so we'll integrate from 2 to y up to certain point y, and the PDF is 1 over 8 times y plus 1. This is okay. One more thing, we already have y on the limit, so let's write some other dummy variable inside. So suppose this is z. Now let's integrate. We can bring the constant outside of the integration, and then we remain with z plus 1 dz. The integration is very simple. This is simply z square divided by 2 plus z, and the limit is 2 to y, right? Okay, so this is 1 over 16 y square plus 2y minus 8. So this is the general CDF. Now probability of y less than 3.2, we can write this as capital F 3.2, right? These notations are basically the same. And now we can put 3.2 in place of y. So this is 1 over 16, 3.2 square plus 2 times 3.2 minus 8. I'll leave this calculation to you. I hope you can do it. Now let's look at another probability. So this is greater than 2.9 but less than 3.2. I can break this, I can separate this. So this is probability y is less than 3.2 minus probability y is less than or equal to 2.9, right? This is how I can break this probability. So 3.2, we have already calculated this. Let's say this is a, this is a minus, and for this one you can simply put the value 2.9 in this. So this is 2.9 square plus 2 times 2.9 minus 8, and this is how you can obtain your answer. All right, now let's move on to the next question. In this question you are given the PDF. So when x is greater than 0 but less than 1, PDF is 1 over 3. When x is greater than 2 but less than 4, PDF is again 1 over 3, and elsewhere it is 0. And this time you are asked to calculate the CDF, that is cumulative distribution function of the random variable x. Okay, so now to visualize these PDFs, let me draw the number line. So suppose this is 0, 1, 2 and 4. So from 0 to 1, the PDF is 1 over 3. From 2 to 4, PDF is 1 over 3. And from 1 to 2, PDF is 0. And above 4, the PDF is again 0, right? So now to calculate the CDF, we need to integrate from the lower limit up to some point x. But now we do not know where x lies. It could be in between 0 to 1, maybe in between 1 to 2, or 2 to 4, or above x. Okay, above 4. So we are not sure where x exactly lies. So we need to we need to find out the CDF for each range. So let's do it. So if x lies in between 0 to 1, then the CDF will be, so this is CDF. We need to integrate. Our lower limit is 0, so we'll integrate from 0 to x, and PDF is 1 over 3. I'm writing y because we already have x on the limit, right? The integration of this is simply 1 over 3 x. Now if x lies in between 1 to 2, then the CDF will be, again we'll integrate from 0 to x, and the function PDF, let me write this y dy. So now we need to add the probability from 0 to 1, okay, and then we'll again integrate from 1 to 2. So this is from 0 to 1, and our PDF is 1 over 3 dy plus from 1 to x, and our PDF is basically 0 elsewhere, right? Elsewhere it is 0. So this is dy. So this is simply 1 over 3. Okay. Now, if x lies in between 2 to 4, then the CDF, now we need to integrate from 0 to 2, and then again x lies in between 0 to 4, sorry, 2 to 4. So this is 0 to 2 fx dx, and then x lies in between 2 to 4, so 2 to x. So let me write this y dy. Okay, so from 0 to 2, this is simply 1 over 3, right? So this is 1 over 3, and from 2 to 4, the PDF is 1 over 3. So this is 1 over 3 dy, and if you solve this, you'll get 1 over 3 plus 1 over 3 times x minus 2 over 3, and if you simplify this, you'll get 1 over 3 times x minus 1. Okay, now if x lies above 4, then you can simply tell the CDF would be 1, because the sum of the probabilities at the infinity, in this case at 4, above 4, is simply 1, right? So f infinity is 1. This is CDF. So now there is a standard representation of CDF, so we need to write in a standard manner. So CDF, so when x is less than 0, CDF is 0. When x is greater than or equal to 0 but less than 1, CDF is 1 over 3x. When x is greater than or equal to 1 but less than 2, CDF is 1 over 3. And when x is greater than or equal to 2 but less than 4, this is 1 over 3 times x minus 1. And when x is greater than or equal to 4, the CDF is 1. So this is the standard representation of CDF. This is how we should write the CDF. All right. Now let's move on to the next question. In this question, you are given the PDF. So when z is greater than 0, PDF is k times z times e to the power minus z square. And when z is less than or equal to 0, PDF is simply 0. Now in this case, you are asked to calculate the value of the constant, that is k. So this constant. Now this question is very simple. You simply need to integrate the PDF and equate it with 1. That's the concept of the PDF, right? So this is integration from 0 to infinity. Our lower limit is 0. So 0 to infinity, ke times, it's z e times z square dz equals to 1. Now the main problem in this question is to integrate the function. People usually get confused while doing the integration. So let's substitute the value t in place of z square to make the integration simple. So let z square equals to t, and we are going to differentiate this with respect to t. So this is 2z dz equals to dt. Now we already have z dz, so let's make this z dz. So this is dt by 2. So you can directly replace z dz with dt by 2, right? And we also need to care about the limits. So our function is z square equals to t. So when you put the value z equals to 0, you'll get t equals to 0, z equals to infinity, t equals to infinity. So there is no change in the limit. Now let's put all the values. So this is simply 0 to infinity. We can bring constant outside, and z dz is simply dt by 2. We can write 2 outside, so this is dt, and e to the power minus t, right? Okay, now k divided by 2 is outside, and the integration of e to the power minus t is simply e to the power minus t divided by minus 1. Limit is 0 to infinity. This is equals to 1. Now k over 2, let me write the minus outside. Now e to the power minus integration, you can simply put the values now. E to the power minus infinity, and then e to the power 0. This is equals to 1. So this is k over 2 minus k over 2. E to the power minus infinity is 0. E to the power 0 is 1. So from here you'll get the value of the k as 2. Okay. Now let's move on to the next question. In this question you are given the PDF. So when x is greater than 1, PDF is 2x to the power minus 3, and elsewhere this is 0. You are asked to check whether its mean and variance exist. So you know, mean is simply expectation, and variance is expectation of x square minus whole square of expectation. Okay, so expectation of x is the integration x times PDF, right? So this is 2x to the power minus 3, and the limit is from 1 to infinity. This is dx. We can bring 2 outside, and the integration of x to the power minus 2 dx. This is 2. The integration of x to the power minus 2 is simply minus 1, and the range is 1 to infinity. So this is minus 2, and 1 over infinity is 0, minus 1. So this is 2. Okay, so mean exists. Now what about the variance? So for variance we need to calculate expectation of x square. So this is again from 1 to infinity. In place of x we write x square, and then PDF dx. We can bring 2 outside. So this is from 1 to infinity, x to the power minus 1 dx. Or we can write this 1 over x. Now the integration of 1 over x is log x. So this is log x, limit is 1 to infinity. Now log infinity is infinity, and log 1 is 0. So this is simply infinity, right? Now variance is expectation of x square minus whole square of expectation. So this is infinity minus 2 square, which is infinity. And this means variance does not exist. All right, so this is how we can check mean and variance. Let's move on to the next question. So the question is, if x is the number of points rolled with a balanced die, find the expected value of this function 2x square plus 1. So you are asked to calculate the expected value of this function. Okay, so now what is x? X is the number of points rolled with a balanced die. So what are the numbers that can appear on the dice? So let me draw the table. So either 1 can appear, 2 can appear, 3, 4, 5 or 6, right? And what is the probability of each outcome? This is 1 over 6, 1 over 6. The probability of each outcome is 1 over 6. Okay, now we can calculate the expectation of this function. This is simply the expectation of 2x square plus 1, right? Now, due to the property of expectation, you can bring the constant outside, and also you can separate the terms of the expression. So if you can separate this, expectation of constant is just a constant. This is 2 times expectation of x square plus 1. Now the reason I drew this table is to find out the expectation of x square. So let's find out the expectation of x square. Expectation of x square is simply x squared times probability. This is x squared times probability. So this is 1 squared times 1 over 6 plus 2 squared times 1 over 6 and so on up to 6 squared times 1 over 6. All right. So this is how you can get the expectation of x squared. Suppose this is a. I leave the calculation to you. So this is 2a plus 1. All right. So this is how you can solve this question. This is not too complicated, very simple. Now let's move on to the next question. The question is, a lot of 12 TV sets include 2 white cards if 3 of the sets are chosen at random for shipment, how many sets with white cards can the shipper expect? So please focus on this word, expect, to send to the hotel. Okay, so this is the question. So the question is saying that out of 12 TV sets, there are 2 white cards and the remaining 10 are non-white cards. We don't know about the remaining. Okay, and you are asked to calculate the expectation, okay, that the white cards can shipper expect to send to the hotel. Okay, so what is the random variable? The random variable X is number of TV sets with white card the shipper sends to the hotel. Okay, so out of 2, shipper can expect to send 0, 1 or 2, right? These are the possibilities. Now what are the probabilities of these outcomes? So let's calculate the probabilities. Let's draw the table. So the possibility, there are 3 possible outcomes: 0, 1 or 2. So what is the probability of sending 0 white cards? So there are total 12 cards, 12 TV sets, and we have to choose 3, right? So we have the we can choose 3 outcomes, right? So there could be either no cards, 1 cards or 2 cards. Okay, so out of 2 white cards, we can choose 0 cards, and out of 10 non-white cards we can choose 3 cards, and this is how you can you can get 0 white cards, right? Similarly, the denominator in this case will be same, and here as well. So out of 2 white cards you can choose 1, and out of 10 non-white cards you can choose 2. So you can see that the sum of these lower numbers is exactly 3. Okay, 0 plus 3 is 3. Okay, and the sum of the upper numbers is exactly 12. So this is how you can confirm that you are doing the right calculations. And out of 2 white cards you have to choose 2 in order to send 2 white cards to the hotel, and out of 10 you can choose 1. So these are the probabilities. Okay, now expectation is simple. Expectation is simply 0 times this probability. So this is X times probability. So 0 times this probability, 1 times this probability, and 2 times this probability, and you will get the expectation. I'll leave the calculation to you. Let's move on to the next question. In this question you are given the PDF. When X is greater than 0 and less than 1, PDF is 4 over pi times 1 plus X square. Square is inside the bracket, and elsewhere this is 0, and you are asked to calculate the expected value, that is EX. So EX is integration X times PDF, right, which is 4 over pi times 1 plus X square, and this is dx, and the limit is from 0 to 1. 0 to 1. We can bring 4 over pi outside of the integration, so the remaining terms are x over 1 plus x squared dx. Now for this kind of integration you need to use substitution method. So let's substitute 1 plus x square with y, and let's differentiate this. 2x dx equals to dy. So we can replace dx with, sorry, 2x dx with dy, right? And then we also need to care about the limits. So this is our function. Let's put the limiting values. So when you put x equals to 0, you'll get y equals to 1, and x equals to 1, you'll get y equals to 2. Now let's substitute all the values inside the integration. So this is 4 over pi. Okay, we can make some adjustment here. We can write 2 over pi and send 1 2 inside, so that we can make this 2x dx. Okay, so that it will be easier to substitute dy directly. So this is 2x dx over 1 plus x square. So now this is 2 over pi, 0 to 1. Okay, so now the limit will change. Now the limit will be 1 to 2, and 2x dx will be dy over 1 plus x square is simply y. So the integration of 1 over y is log y, and the range is 1 to 2. So 2 over pi log 2 minus log 1, and we know log 1 is 0. So this is 2 over pi log 2. Okay, so this is the answer. Let's move on to the next question. So in this question, you are given that a random variable x whose probability density function is proportional to 1 plus x to the power minus 4, and the range of x is from 0 to 1. Okay, and you are asked to determine the expectation. So this is the question, and there is second part as well, variance. Okay, so let's do this. So what is expectation? Expectation is basically x times PDF integration, right? But in this question you are given that the probability density function is proportional to this function. So probability density function is proportional to 1 plus this function, right? And when you remove the proportionality, you need to put a constant. So this is k times 1 plus x to the power minus 4. All right, and the limit is 0 to 1. Now before we do the expectation, we find the expectation, we need to find out the value of this constant. All right, so we know that this integration of the PDF is 1. So the integration from 0 to 1, this is 1 plus x to the power minus 4 dx is equals to 1. Now here we need to use the substitution method. Let's substitute 1 plus x equals to y, and this is dy equals to dx. Also we need to care about the limits. So when x is equals to 0, y is 1, and when x is 1, y is 2. Okay, so the limit is 1 to 2. Let's bring the k outside, and this is y to the power minus 4 dy. This is equals to 1. And integration of y to the power minus 4 is simply y to the power minus 3 over minus 3, and the range is 1 to 2. This is 1. Okay, and when you put the values, that is the range, inside the bracket, you'll get k equals to 24 over 7. So this is the value of k. Now we need to find out the expectation. So expectation is simply integration over 0 to 1. K is 24 over 7, and function is 1 plus x. Also we need to put here x to the power minus 4 dx. We can bring the constant outside, 0 to 1, and this is x, 1 plus x to the power minus 4 dx. Again, here we need to use the substitution. So the range will be 1 to 2, and x will be substituted with y minus 1, right? And 1 plus x is y minus 4 dx, sorry, dy. And we have 24 over 7 outside. So this is 24 over 7, and let's multiply this term inside the bracket. So this is minus 3, and this is minus 4 dy. And then 24 over 7, integration of minus 3 is, this is minus 2, y to the power minus 3 over minus 3, and the limit is 1 to 2. And when you solve this, you put the values inside the bracket, you'll get 2 over 7. All right, now for the second part, you need to calculate the expectation of x square. So expectation of x square, again the calculation is very much similar. So this is 0 to 1. Okay, let me write it directly. You can bring this constant outside, 0 to 1. This is x square, 1 plus x to the power minus 4 dx. Again, we need to use the substitution. So this is 24 over 7. This is 24 over 7. 1 to 2. This becomes y minus 1 whole square, y to the power minus 4 dy, right? Now 24 over 7, this is 1 to 2. Now we can open this bracket, this whole square, y square minus 2y plus 1, and this is minus 4. Okay, now you can simply multiply this thing inside the bracket. So this is 24 over 7, 1 to 2, y to the power minus 2, minus 2, y to the power minus 3, plus y to the power minus 4. And now this is very easy to integrate. 24 over 7, this is minus 1 to the power minus 2 plus minus 3, and the limit is from 1 to 2. Okay, now when you put the values, you'll get the answer 1 over 7. Okay, so the variance is expectation of x square minus whole square of the expectation. So ex square is 1 over 7, and ex is 2 over 7. So this is 2 over 7 whole square, and you'll get the answer. So this is all about the discrete and the continuous random variable. Okay, so let's stop the video here, and in the next video I'll talk about distributions. So thank you so much for watching this video.